This is a continuation of the Chapter 12 review with problem 14. In problem 14 we're doing volume, and in problem 14 we have the volume of a prism. This is a very basic formula. It's simply length times width times height. So let's go ahead and start this. Volume is 1.5 times 2.1 times 3.6. That gives us 11.34 cubic meters. It's actually not an approximation. It's an exact value there. And because we're multiplying meters by meters by meters, that's where the cubic meters comes from. All right, very basic problem. Let's move on to number 15. In problem 15, we have an oblique cylinder. And it's an oblique cylinder because the axis is not perpendicular to the base. So in this oblique cylinder, we can find the volume the same way we find the volume of any cylinder. Because of Cavalieri's principle, we know that because these cross-sectional areas are going to be the same from one base to the other along every piece of the height, that the volume of this cylinder is the same as the volume of a cylinder with the same area of a base and the same height. So to find that volume, it's just the volume formula of a cylinder. 15 volume equals area of the base times height. Just that simple, which is pi r squared h, which is pi, r is 2 squared, h is 8. That gives us a volume of 32 pi, which is approximately 100.5 cubic meters. Actually, that's cubic millimeters. All right, now let's move on to problem 16. In problem 16, we're going to have a little bit of extra work here. This is a regular pentagonal prism, and you can see that the bases are regular pentagons. We have a length of 4, or a height of the prism, if you will, and they give us only the side length. So that means we're going to have to be calculating the apothem of this regular polygon. Let's go ahead and get started with this. This is going to take a little bit of extra intuition here. The volume is area of the base times height. The area of the base is the thing that we have to calculate. So we know that area of the base is the area of a regular polygon, which is 1/2 pa, 1/2 perimeter times apothem. Perimeter is straightforward. The apothem is going to require a little bit of work. So let's go ahead and draw our representative central triangle. That is a triangle here with the center and the radii being the sides of the triangle. Let's draw in our apothem. We know that this side length is 2, so this piece is 1, because in an isosceles triangle, the altitude to the base is a bisector of the base. We know that this is a pentagon, so the central angle is equal to 360 divided by the number of sides, which is 72. So this angle is 72. We divide that by 2, and that gives us 36. Because the altitude bisects this angle is 36 degrees. Now, using these ideas, we can find the apothem. And the apothem is going to be some old horse, can't use it, don't have the hypotenuse, caught a horse taking oats away. It's tangent. Tan 36 equals taking oats away. 1 over apothem. Solving for apothem, apothem equals 1 over tan 36. Now we're going to calculate that and store the value. I always circle the values of my stored elements. So now we have the apothem here, and we should be able to calculate the area of the base. This is going to give us 1/2 perimeter is 2 times 5. So it's 2 times 5 times the apothem that we've stored. So this is going to give us 5 times the apothem here. Apothem times 5. So let's go back over here, and our area of a base is 5 times the apothem we had stored times h. The h is the height or length of the prism, so that's times 4. If we put that into our calculator now using this stored value for the apothem, we get approximately 27.5 cubic yards. So altogether not a terrible problem, but again, very important to organize your work so that you can follow the flow and you don't get lost. All right, let's move on to problem 17. In problem 17, we're being asked to describe how changing certain dimensions affects the volume of the prism. So we're going to do something similar as what we did when we were dealing with changes in area and changes in perimeter. This time we're doing it with volume. First thing, let's go ahead and write down what the expression is going to be for the volume of this particular prism. In this case, we have a triangular prism. It's actually a right triangular prism, and luckily they give us all the pieces, so our work is going to be relatively minimal. But let's continue on. We have volume equals area of the base times the height, which is 1/2 the base times the height of the triangle. Now, so that we avoid confusion here, I'm just going to put height triangle and height prism, just so that we can keep these straight. So that's area of the base times height of the prism. Now let's go ahead and put in our values and see what we get. This is 1/2. The length of the base is 7 times the height of the triangle is 24 times the height of the pyramid, which is 30. That's going to get us 2520 cubic centimeters. Now let's take a look at what's going to happen with A. So for part A, we're going to modify the height of the prism by 1/3. So let's take a look at this formula. If we rewrite this formula and we say that it's 1/2 the base times height of the triangle times 1/3 the height of the pyramid, because it says we're multiplying the height of the pyramid or the prism by 1/3, then what's the overall effect on volume? Well, the only difference between this expression and this one is that this one's being multiplied by 1/3. So we would expect that this new volume is going to be 1/3 the volume of this. So let's see if that works out that way. Let's go ahead and put in our values. We have 1/2, 7 times 24 times 30 times 1/3. And you can clearly see here that we're going to take the 30 divide it by 3. So this value is going to come out to be 1/3 of this. But let's calculate it out. This gives us 840 centimeters cubed. And we can verify the ratio by saying 2520 divided by 840, that is 3. Therefore, we would say that the volume has decreased by a factor of 1/3. Now for part B, let's do something similar. So for B, what we're going to do is rewrite the formula, but this time it says all linear dimensions are multiplied by 2. So that gives us 1/2, and this is going to be 2b times 2h, the height of the triangle, times 2 height of the prism. Now you can see in this instance that the difference between this form, the first form here, and this new form is, this one is 2 times 2 times 2, 8 times greater. So we can surmise then that the volume is going to increase by a factor of 8. And in fact, if we put this into our calculator, we have 1/2 times 2 times 7 times 2 times 24 times 2 times 30. We would get 3 times this value. So let's see if that's true. We get 2160 cubic centimeters. And if we divide this by this, we in fact get 8. So this is our new value, and this is in fact correct. Our volume increased by a factor of 8, and that's what it was looking for. All right, let's go ahead and move on to problem 18. And we'll start that problem at the beginning of the next video, so I will talk to you in the next video.